welcome to the next installment of Brain Breakers. Today we're looking at this infinitely nested radical problem that turns out to have quite a surprising outcome of just very simple quadratics maths. So, as you can see on the screen there, we just have a square root of 6 plus square root of 6 plus square root of 6 plus all the way down infinitely many times, and we're trying to find the value of this expression. Now, an analogous problem to this problem is the idea of converting an infinitely recurring decimal value into a fraction. We see an infinite pattern recurring here, which is the infinite 6 decimal place recurring, and we need to try to eliminate that in some way, which is what we're trying to do with the other problem. Now, the good thing is that this is something that, well, at least in Australia, we learn in early years of high school, and so it's great to see that that can be applied to higher level of maths here as well. Now I've shown the decimal places with the 3 dots to show that it infinitely recurs because it's a little bit easier to see the decimal places visually rather than just putting the dot at the top to show that recurrence. The way that we handle these problems is by first giving this value, this expression, an unknown value in the form of a variable. So what we're going to do is we're going to say, let 6.6 recurring equal x. And what we're trying to do is we're trying to eliminate this infinite pattern, because if we can eliminate this infinite pattern, which is something we don't really know how to handle, we can get back to something that has a finite pattern, or just a finite value, which is something we know we can handle. So what I'm going to try and do is I'm going to try to perform an operation to both sides of this equation that will allow me to maintain that pattern in a way that I can cancel it out later. The best way to do this for this scenario is to just simply multiply both of those sides of the equation by 10. That allows me to get 10x on the right side, and then it allows me to just move that decimal place once over so that I get 66.6 recurring. And the cool thing about that is I can see my original value, 6.6 recurring, which has the value of x, already in that value. Now all I need to do is cancel it out, and I can pretty easily do that by simply subtracting that original x value. If I do subtract that value, well, all of those places will cancel, and I'm just left with zeros in all those places, which means I'm just left with 60. I also get 9x on the right because I have 10x minus x. Now it's very easy to handle this. All I need to do is divide by 9 on both sides, and I get 60 on 9, which simplifies to 20 on 3. And we know that that's correct because 6.6 recurring is, as we probably all know, 6 2/3, and 20 on 3 is 6 2/3. So let's try and use this approach with the original problem of the infinite nested radical. Therefore, all I'm going to do is I'm first going to start with letting that expression equal x. And what I want to do is perform an operation to x in order to maintain that pattern and then be able to cancel out the infinite pattern later. So first things first, let's define that x has to be greater than 0 because this is the square root of some value, meaning that it must be positive. The operation that I can probably guess I'm going to do to both sides is just continue on this pattern of adding 6 and square rooting. So why don't I do that? I'll add 6 to both sides, so I get 6 plus the infinite expression equals 6 plus x, and then of course I would just need to square root all of that on both sides again. Now you see that I have on the right side the square root of 6 plus x, and on the left side I'm actually just left with the exact same expression that I started with. Because if I've done this operation, this plus 6 and square root infinitely many times, well then doing it once more is still infinitely many times. So that expression on the left there is actually just equal to what we started with, which is x. Now I have x equals the square root of 6 plus x, and this is much easier to handle. So giving us a little bit more space, I'll solve this pretty basic equation. What I need to do is square both sides. That cancels out the square root, and I'm left with x squared equals 6 plus x. Then it becomes a pretty basic quadratic problem. I move all of my terms onto one side and I make it equal to 0. I now factorize that quadratic and I use my null factor law to end up with x equals 3 or x equals negative 2. The great thing is we also know that we started with x must be greater than 0 and therefore x must equal 3. And there is the solution to the problem. Let's see if that actually does happen when I put this into a calculator. Well, if I'm going to do that, I'm going to need to obviously start with some value. I don't know what this starting value is because this is meant to go on infinitely. I think the most basic example to start with would just be to start with square root of 6. Let's just see what happens. So I'm going to start with that, and then to that I'm going to get my square root. I'm going to add 6 to the answer, and I'm going to calculate that. You can see that it's pretty close to 3, and as I continually reperform that operation, you can see that it actually approaches 3. Now that's all well and good, because I started with a value that was pretty close to maybe what I assumed it would be. But what if I started with something that was clearly not what it should be? Like if I started with -1, because -1 obviously will not be the value of the square root, the end value of the square root. Well, let's give it a go then. I could simply add 6 to that answer and square root. And I could just continually perform that operation, and again you see that it eventually approaches 3 again. Let's take a look at why that is. So let's just give this a go by starting with some constant k. What I'm going to do to that is I'm going to perform this operation many times. So I'll add 6 and square root, I'll add 6 and square root, I'll add 6 and square root, and I'll do this infinitely many times, let's say. And I want to figure out what the value of this is here if I've done this infinitely many times, regardless of what my k value is. So again, let's use the same approach that we did before. Let's just say that that's equal to some other variable y. And you can probably see where this is going, because if I do the same thing that I did before, let me add 6 to both sides and then square root to keep that pattern going. And you can see there that my left expression is actually equal to what we started with, again because this infinite pattern, though I've done it one more time, obviously that is still the infinite pattern. That is still that same infinite pattern. I therefore am left with just y equals the square root of y plus 6, and that will be the exact same equation as what we did with x, and so we'll therefore solve to be y equals 3 again. So you see that it doesn't actually matter what value I start with inside my infinitely nested radical. I can obviously just always end up with this value of 3. So hopefully that makes sense to how that works on the calculator. That value k could be anything as long as it doesn't make the square root negative. So anything that's greater than -6. That means that I could do something like whatever this is, maybe a billion or something. Start with a billion, and let's do that process again just to verify that it really doesn't matter what I start with. That value will always approach 3 if we do it enough times. So let's add 6 square root and then continually perform that process, and lo and behold, we approach 3 yet again. Very cool.